Hello everyone. So today we are starting chapter number 1 from Embedded System course. Chapter number 1 is titled as 8051 Programming in C. The course outcome of this chapter is EIF402 Understand the fundamentals of Embedded C programming for 8051 microcontroller. The contents of this chapter: first point is overview of 8051 architecture. Second, data types and time delay in 8051 using C. Third, IO programming in 8051 using C. Fourth point, logic operations in 8051 using C. Next, fifth point, data conversion programs in 8051 using C. 6. Accessing code ROM space in 8051 using C. And last point is data serialization in 8051 using C. So for this chapter we are going to conduct 8 number of lectures, and weightage in terms of marks in term and exam is 10 marks for this chapter. So as the content show, in this chapter we are going to study how to program 8051 controller in C for embedded system development. So before proceeding towards actual contents of this chapter, we will have brief introduction to embedded systems. So we are going to discuss first what is embedded system, next embedded system functions and characteristics, then embedded system architecture, then types of embedded systems, life cycle of embedded systems, design and development of embedded systems, and then we can have question answer session live. So first point, what is exactly embedded system is. Okay, so to understand what is embedded system, so we will first take examples of embedded systems. Most of these examples are consumer products like TVs, mobile phones, fax machines, printers, photocopying machines, washing machines, automobiles, camera, microwave, etc. So all these consumer products are embedded systems. Majority of these products you have at home. Okay, so all these products are embedded systems. All these products again provide services in real time, that is user need not wait too long for action. Okay, so that is called as real time operation. For example, if you want to do a call on your mobile phone, then you have to just select contact number and you have to just dial that number, and within seconds that call will get connected. So you need not wait too long, okay, to perform any operation on any of these products. So that is called as service in real time. So all these embedded gadgets provides number of operating flexibility in different modes. These variations and flexibility of functionality is achieved by a very flexible device which is sitting at the heart of such consumer products, and that is nothing but customized microprocessor or microcontroller, and that is known as embedded processor. For example, take an example of mobile phone. So at the heart of any mobile phone you will have its processor, okay, which controls all the operations of that mobile phone, or whatever features that mobile phone is offering. So it controls the operation of these features. Okay, so that is called as embedded processor. In addition to embedded processor, there are other components needed which are actually divided into two parts, that is hardware and software. More details we are going to study next. So other than these consumer products, these are few examples of embedded systems. For example, uh, industrial robots picture you can see, that is industrial robots. You'll find such robots in industry. For example, in automobile industry, on manufacturing assembly line, you will find such robots performing uh, certain operations. Okay, so such a industrial robot is an example of embedded system, and which should perform in real time. Okay, another example is GPS receivers, digital cameras, DVD players, wireless routers, MP3 players. Nowadays, MP3 players are absolute, nobody is using. Uh, then set-top box. So this is very common to you. At your home, you have set-top box connected to your TVs. So that set-top box is actually embedded system. Inside that set-top box, there is an embedded processor which controls the operation of that set-top box. Then gaming consoles, photocopiers, that is its common name is Xerox machine, you call it. So that is photocopiers, microwave ovens, etc. So many examples are there of embedded system. Or for example, today's vehicles also embedded with control unit that controls or provides various functionalities. So that is also an example of embedded system. Now let us define embedded system. So there are so many definitions of embedded systems, but we are taking only two of these, which I feel suitable to explain or to define embedded system. So the first definition is the device or product housing embedded processor is known as embedded system. Okay, that means any device you take or any product you take, inside which if there is a microprocessor or a microcontroller which is controlling the overall functionality of that product or device, so that is known as embedded system. Another definition of embedded system is any device that includes a computer but is not itself a general purpose computer is called as embedded system. Okay, so see here, uh, for example, your desktop computer system or laptop, it is not embedded system, because so that can be used for general purpose. General purpose means it can be used for any or number of purposes. So it is general purpose device. So any embedded system is not a general purpose device, because in any embedded system the embedded processor is employed to perform a particular task. So that is embedded system. But your desktop computers or laptops can be used for various purposes, means whatever processor inside these desktop computers and laptops, that can be employed for any or number of purposes. So that is not an embedded system. Okay, so that is second definition. Any device that includes a computer but is not itself a general purpose computer is called as embedded system. Now what are functions and characteristics of any embedded system? So to the left hand side, functions that embedded system performs are listed. There are three functions performed by any embedded system. First, respond. Second, monitor. And third, control external environment using sensors and actuators. Okay, so any embedded system, so it will monitor certain parameters, and accordingly it will perform some operations, so that is called as a response. Okay, and that is to this this response is to control external environments using some actuators and sensors. So these are functions of any embedded system. So any embedded system monitors, then it responds and it controls. Okay, so these are functions of any embedded system. uh, what are characteristics of any embedded system, or what should be characteristics of embedded system? So first, any embedded system should provide sophisticated functionality. Second characteristics, it should provide real-time operation. So what is this real-time operation we are going to study? Third, low manufacturing cost. Manufacturing cost of any embedded system should be low. So this requirement is everywhere, you know. Then fourth characteristic, application dependent microprocessor or microcontroller should be used in any embedded system. Then fifth, restricted memory. So whatever amount of memory is required in particular embedded system, so that much memory will be used. Means there is a restriction of use of memory, so that cost will reduce. So that is restricted memory characteristic. And last characteristic of embedded system, low power consumption. Any embedded system, if you take, it should consume less power. So these are characteristic. One example is stated here, that is example of one embedded system, that is washing machine, to explain these characteristics. So inside washing machine, automatic washing machine, so there is a embedded system which controls the functionality provided by this washing machine. Okay, so to provide this functionality on this washing machine, there is a control panel. By using that control panel, you can set that washing machine, and accordingly washing machine will perform operations. So the embedded system, inside this embedded system, there is an embedded processor. With that embedded processor, there is a memory and other peripherals with software installed in the memory of that embedded processor. So all these things are there. And when you operate this washing machine, for example, if you put clothes for washing inside this washing machine, and if you start, so it will derive the time required to perform number of operations. Okay, and accordingly, once you start that washing machine, accordingly that washing machine performs number of actions in a restricted time. Okay, so this is called as actually sophisticated functionality. That is one of the characteristic of any embedded system. It provides real-time operation. Obviously, whatever the time, for example 55 minutes at the start, if it shows, it performs that washing operations in 55 minutes, or finishes washing operations in 55 minutes. Low manufacturing cost, so this is true with each and every product. Then application dependent microprocessor or microcontroller, that is embedded processor used inside washing machine. So that is application dependent, means whatever number of and amount of peripherals required, so that type of microprocessor or microcontroller is used inside washing machine. The restricted memory, that means whatever memory required, whatever amount of memory required to store the program or software of washing machine, so that much memory is used. And low power consumption is there. So these are functions and characteristic of embedded system. Now next, architecture of embedded system. So this is generalized architecture, or simply we can say block diagram of general embedded system. Now see, here uh, there are solid lines, so which is actually system bus, that is a bus that connects various peripherals. At the heart of this embedded system, there is a MUC, means microcontroller. Okay, and to this microcontroller, user interface is there, through which user can interact with the embedded system, or user can input commands through this user interface. Microcontroller is connected through bus to system bus. It is also connected to dotted block, that is RTOS, that is called as RTOS, that is a real-time operating system. that is software actually. So if you see at the bottom right hand side, so the hardware of this embedded system architecture is for that solid lines or solid blocks are used, and to indicate software blocks dotted blocks are used. Okay, so with microcontroller is connected to user interface RTOS. Under RTOS you can have controller processes, user interface processes, that is software, part of software. Below the system bus there are number of blocks, so there is a digital signal processor if required, that can be used to process digital signal. It is having its software, that is DSP assembly code. Then system bus is also connected with another digital signal processors here if required. uh, then coder decoder is there. Okay, so this is a block diagram of embedded system, generalized block diagram of embedded system. Now embedded system types. So depending on time constraints, there are two types of embedded system: a real-time embedded system and non-real-time embedded system. So what is real-time embedded systems? So in case of real-time embedded systems, uh, these embedded systems should finish operations by deadlines. Okay, and majority of embedded systems are of this type, that is real-time embedded systems. Under these real-time embedded systems, there are two types. First one is hard real-time embedded system, in which missing deadlines causes failures. And examples of these hard real-time embedded systems are missile with tracking system, in which suppose if deadline is not achieved by embedded system, then there might be failure, means whatever the target of missile, that may get missed. Okay, in also washing machine, if the for performing operations, if time that is derived by embedded system 55 minutes, and if it is not reached, that means it is a failure. Another example of hard real-time embedded system is robots on assembly lines. For example, in automobile industry, for assembling of vehicles, robots are there, and if any one of these robot does not achieve its function in time, then there will be failure of that assembly line. Second type of real-time embedded system is soft real-time embedded system, and in such a soft real-time embedded systems, missing deadlines results in degraded performance, not failure. See the difference between hard real-time and soft real-time. In case of hard real-time, missing deadlines causes failures, but in case of soft real-time embedded systems, missing deadlines results in degraded performance. For example, DVD player. So in case of DVD player, if suppose reading from DVD, it takes some time and it misses a deadline, then there will be degrading in performance. Okay, so you cannot watch whatever video in a continuous mode in that case. So this is called as degraded performance, so that is acceptable. Also mobile phone. So while using mobile phone, if you dial a particular number, sometimes it takes long times, but that does not affect. Okay, so missing that deadlines just degrades performance of that embedded system. So such embedded systems are called as soft real-time embedded systems. Second major category of non-real-time embedded systems, in which no deadline or time bounding on operation is there. Such embedded systems are under non-real-time embedded system category. Now depending on type of functionality, we can also have types of embedded systems. For example, similar to general computing, for example PDA, video games, set-top boxes, automatic teller machines, ATMs. So these are examples of general computing embedded systems. Second type is control systems. For example, feedback control of real-time systems like vehicle engines, flight control, nuclear reactor. So These are examples of control system type of embedded systems. Then signal processing type of embedded systems, for example MP3 player, DVD player, radar, etc. These are signal processing type of embedded system in which signal gets processed. Okay. And last category or type of embedded system is communication and networking. For example, cellular or mobile phones, internet applications. So these are examples of communication and networking type of embedded systems. Now, life cycle of any embedded system, that means the stages through which any embedded system travels from start to end, that is called as life cycle. So embedded system also have life cycle, and this life cycle is divided into 6 stages. First is requirements. You will get requirements for embedded system. Then second stage, design stage, in which that embedded system will be designed. Then in third stage, that embedded system will be manufactured. In fourth stage, that manufactured embedded system will get deployed for its operations. In fifth stage, logistics, that means maintenance if required from the customer end, and that will be provided by manufacturer of that embedded system. And last is after certain period, that is defined by manufacturer, so that embedded system may retire for the function to which it was employed. For example, for computer systems, desktop computer system, the age is defined as 6 years, means after 6 years these computers or laptops can be retired. Okay, means we can stop using these laptops and desktops, and we can procure new ones. Like that we can also do with embedded system, that is the retirement of embedded system. So this is the life cycle of embedded system. And last point is embedded system design and development steps, means if you want to design and develop embedded system, what are the steps? Okay, so these are very much similar to life cycle of embedded system. So first thing you have to do if you want to design and develop embedded system is the requirements. You have to take requirements from customer. Okay, so what customer wants. Okay, so that requirements you have to collect from customer by analyzing customers requirement. Okay, so that is the first step. Second is from that requirement you can state specifications of the embedded system being developed or designed. Then you can draw from these specifications, you can draw architecture or block diagram, simply block diagram of the embedded system of that particular customer. Then each block can be designed, that is called as components design. So in that embedded system number of blocks are there, so designing each block in detail, that is the next stage, that is the components design. And fifth stage, system integration. After designing and testing each components of your embedded system, then you will interconnect all these components to provide full functionality, and that is called as system integration. After that you will test your embedded system under certain conditions or standard conditions, and then you will manufacture that embedded system and supply it to your customer. Okay, so these are the design and development steps of any embedded systems. Okay, so this is about introduction to embedded system. I think things now are very clear to you about embedded system. So if any questions in live session, we can take questions on it. You just study this video, and in live session we will have question answering session. Okay, so thank you very much.